Hello students, welcome back to the session. Grade 10 physics subject is, and the topic is chapter number 13, magnetic effects of electric current. We have divided into different parts, and today is this the first part, that is part A. In this part, students, we are going to discuss about magnetism, magnetic field and Oersted experiment. What are we going to discuss? We are going to discuss about magnetism, magnetic field and Oersted experiment. So now the magnet, the general topic. What is a magnet? So it is a material which can attract magnetic substances. What is that? It is a material which can attract magnetic substances such as iron, nickel, cobalt, etc. So which has a tendency or a capacity to attract magnetic substances is called a magnet, and every magnet will have two poles, that is your north pole and south pole. These are the different types of magnet, a general introduction from the past earlier grades. So what are the properties of a magnet and how this is useful to this chapter? That everything we are going to discuss, not to worry, just have a recap and further we'll continue along with the topics. So this is a general topic here, you got it, that is your properties of a magnet. Each magnet, properties of a magnet, see, as it is having two poles, north pole and south pole, like poles repel each other. When you bring two north poles of two different magnets, they repel. When you bring two different poles of different magnets, they attract. That is, north will repel, north south will attract. Like poles repels and like poles attract. A freely suspended magnet always point in north south direction. If a magnet is given, if you want to find out the direction, that is the poles of a magnet, you take a thread, tie it at the center and leave freely. That is, you need to suspend it freely. After some time it will come to rest. By the help of the geographic directions north, south, east and west, one part will be directed towards the north direction, another part will be directed towards the south direction. So the part which is directed towards north pole, north side, we'll call it as a north, and the other one, opposite one, will be the south. So magnetic force is strongest at the poles. Point to remember. The magnetic force is always strongest at the poles. So what do you mean by magnetic field? Please check the figure. So many couple of terms and definitions are related in this image. The region around a magnet where its magnetic force can be experienced is called a magnetic field. You can see the lines. If an object is placed outside the lines, the magnet cannot attract. So the region around the magnet where the force of the magnet, that is a magnetic force, can be experienced, we call it as a magnetic field. Check the arrows as we discussed just now, two poles. One is the north pole and another is the south pole. The magnetic field lines. Magnetic field lines are imaginary lines which are used to represent magnetic field of a magnet. These lines are called magnetic lines of force. By the help of these magnetic lines of force, we can easily know the magnetism. How much is the magnetic force of the given magnet? See, from where to which pole they are starting and ending. They always start from north pole and they go towards south pole. Again they will start from the north pole and they go towards south pole. So direction of a magnetic field. Outside the magnet, field lines will move from north pole to south pole, and inside the magnet they will move from south pole to north pole. Outside, north to south, inside, south pole to north pole. Thus they form closed continuous curves. What do they form? They form closed continuous curves. So here comes the properties of magnetic field lines. They originate from north pole and enter the south pole. Inside the magnet, they return from south to north. They will never intersect. Students, they are not going to intersect. Closer field lines will indicate strong magnetic field. So they formed closed loops. That circular ones are called your closed loops. The strength of a magnet. If you want to find out the strength of the magnet, it depends on the spacing of the field lines. What it will depend? It will depend on the spacing of the field lines. If the field lines are close together, strong magnetic field. If the field lines are farther apart, it is weak magnetic field. Next comes here Oersted experiment. So what happened here? So why did we discuss from the past? So here students, Oersted is one of the scientists who has given the relationship between magnetism and electricity. By the help of electricity, we can produce magnetism, and by the vice versa means. So he is a person who has given the relation. So how? That experiment, that is to show the electric current produces a magnetic field. So when an electric current passes through a straight conductor, that straight conductor is placed near a magnetic field, the compass needle gets deflected. Now see here, you have a magnetic compass, a cell, the circuit. Is this an open circuit? So when it has been closed, the magnetic needle, earlier it always rests on the north-south direction only, as it is was rest when the circuit was open. When the circuit was closed, the magnetic needle started showing deflections. So with this experiments, Sir Oersted had proved that by the help of electricity we can produce magnetism. So what is the conclusion? Electric current produces a magnetic field around the conductor. So magnetic field around a current carrying straight conductor. In a conductor, when it is carrying a current, that is a current is passing in a conductor, how the magnetic field appears. When electric current flows through a straight conductor, concentric circles, circular magnetic field are produced. Check the image here. This is a closed circuit, a switch, a battery, the ammeter, the rheostat. You can increase or decrease the current. So at particular point we place, the circuit is closed, the magnetic compass is placed, and this is a wire is your current carrying conductor. So here you can see the magnetic field lines are produced. How they are produced? In the form of concentric circular magnetic field lines are produced in the form of concentric circles. So what do you observe here? Magnetic field lines are circular and they are centered on the conductor. Strength will decrease as the distance from the conductor will increase. The circle which is close to the loop will have more strength, and the circle which is far from the conductor will have less strength. Increasing the current will increase the magnetic field. Next comes right hand thumb rule. Kindly check properly, and you can place your right hand in this way. The thumb will always point the current, and the folded fingers will point towards the magnetic field. Thumb will always point the current and the folded fingers will point always towards the field, and that is a coil. This is your right hand thumb rule. If a current carrying conductor is held in a right hand, okay, you're carrying a current carrying conductor in your right hand, the thumb will point the direction of the current and the curled fingers will point the direction of a magnetic field. Next comes Maxwell corkscrew rule. Clockwise and anti-clockwise movement. If you are opening and closing, you will move in both the directions, either clockwise or anti-clockwise. So direction of magnetic field and direction of a magnetic field. Check the arrows, check the color properly. Clockwise and anti-clockwise. Direction of current in the downward and direction of the current in the red. Anti-clockwise and clockwise movements. So if a right-handed screw is rotated so that it moves in the direction of the current, then the direction of rotation of the screw will give what it is going to give. It is going to give the direction of magnetic field. If you are turning your right hand, the direction in which you are turning it, that will be your direction of the current, and the direction of rotation of the screw moves in the direction of the current, and then the direction of rotation of the screw will give the direction of magnetic field. This rule gives the same result as the right hand thumb rule. Understood, students? Anywhere, any doubt if you have, you can please use the comment box, chat box, and you can WhatsApp. You can send a message, and this is your channel link, students. Be safe. Be secure. Thank you very much. Bye bye. Good day.